Question 9 of your final exam will be based on the application of calculus. And this will look at the cubic function. The question reads as follows. The diagram below shows the graph of f of x is equals to 2x cubed plus bx squared plus cx. Now what we are given here is an equation of a cubic function which is defined by ax cubed plus bx squared plus cx plus ad. Now with this equation, we know that the value of a here represents the shape of the graph. And so here we can see that our shape would start with a function that is negative and it ends up being positive. So overall, this function is a positive function. That's why we have a positive here and it goes with that shape. The second thing to observe here is that we also have the d here to be a 0. There's no d on this function here. We're adding a 0 here at the end. And we know that d represents the y-intercept of our function. So that means this function will intercept at 0, 0. And that's the reason why here you would see that the function cuts the origin. And perhaps maybe other things that we can mention is that we're not given the values of b and c. So the question might require us to find those values. The question continues to say that p, which is a 3 over 2 and a 9, is a point of inflation. Is a point of inflation of f. And the tangent to the curve at p has a slope of negative 15 over 2. Now we are told that this point p here is a point where the concavity of this function changes. This means that this function from here to here, it is concave down. So we're saying it is concave down. Remember the n here will give you the shape of the graph. It's a set graph. However, when you look at this function from this side, it then becomes concave up. So here we're having a concave up. Remember this u here gives you the shape right there. Now this point here is where the concavity changes from concave up to concave down. It's usually sort of a bend there. If you draw your tangents, you'll find that the tangents that you were drawing here, they sort of change in their shape when they get to that point. The other thing that is very important with this function is that we say this point here is where we have a tangent. In other words, we have the tangent to have a slope of negative 15 over 2. So this is a 15 over 2, negative 15 over 2. And you can see that this is a negative slope because the line, the tangent, is going downhill. Now there's something very important to observe here, is that this gradient is also the same as the derivative of this function at the point 3 over 2. So at this point here, 3 over 2, if we take the derivative of the function f, we should get the same gradient. We should get the same gradient of negative 15 over 2. This is because we said that the tangent and the curve at the point have the same gradient. Remember, the derivative is just the gradient of a curve. I think I've done a thorough analysis of this graph. Now we are doing question 9, and in this question we are given the function f of x is equals to 2x cubed plus bx squared plus cx. The first question here is question 9.1, which requires us to prove that b is equals to 15 and c is equals to a 24. To do that, I'm going to use point P, where I'm going to say my point P is given by 3 over 2 and a 9. And I'm going to find the function values using this point. So that is to say, if I say f of x at 3 over 2, it will then be given by a 3 over 2 all cubed plus b 3 over 2 all squared plus c 3 over 2. Now remember that these are the x and y values. So I'm saying that if our x value is a 3 over 2 here, right, our x value is a 3 over 2, then our y value should be a 9. The whole thing here should be a 9. So the y value at 3 over 2 should be a 9. Now this means that I'm going to have a 9 is equals to now when we say 3 cubed is a 27, 2 cubed is an 8, then if we multiply 27 by a 2, we should get a 27 over a 4. And this side we're going to have a 9, because 3 squared is a 9 and 2 squared is a 4. So we simply have a 9 over 4 here. 9 over 4 times the b there. And the last one is simply a 3 over 2c. Now at this stage, I'm going to multiply both sides by a 4. So I'm going to multiply each term here by a 4 and also here by a 4 and a 4. But what I do on the right, I should also do on the left. Now when we do that, you will see that a 9 times a 4 is a 36, and 27 over 4 times a 4 is simply 27. And also here we're going to have a 9b, and here we're going to really have a 6c, because the 4 here would divide so that I have a 2, and then a 2 times a 3, that should give me a 6. Now when I look at this equation, I think I can reduce it down a little bit by dividing both sides by a 3 again, so that it is much more reduced. Now 36 divided by 3 is a 12, and 27 divided by 3 should give me a 9, and a 9 divided by 3 is really a 3, and 6 divided by a 3 is a 2c there. Now I can group the 9 and the 12 together since they are like terms. So that means I'm going to take the 9 to this side, so that I have a 12 minus a 9, which really is a 3, is equals to this side. I'm still having the 3b and the 2c. I'll call this equation 1. Now you'd notice that here we are looking for two variables at the same time. I have a b and a c. This already we know by experience, and especially doing question 1. As I said, question 1, if you master it, you can answer any question in mathematics. This would mean that, we're doing simultaneous equation. We know that from practicing algebra. Now the question then would be, how do we then do the second equation? How do we come up with the second equation that will be a simultaneous equation to this one? Well, if we look at the information that we have here, this is where we'll come up with the second equation. Now, the first thing that I'm going to do to build the second equation really is to do the derivative of this function. So I'm going to take this function that I have here and compute its derivative. So we're going to take the derivative of f of x, so that now here I'm going to have a 6x, because I'm taking the 2 here. It's going to be 2 times a 3, it's a 6. I subtract 1, I'm having a 2 there. So that means here we're going to have a 6x squared. Then we do the derivative of the second term. So the 2 would come here, it will be a 2b. We subtract 1 there, it should be a 1. So we're going to have here plus 2bx, and we do the derivative again of the last term there. You'll see that here we have a 1. We take the 1 here, it will be c times a 1 is going to be a c. Then we're going to have 1 minus 1, it's a 0. Then we know that any number to the power 0 is just a 1. So that means here I'm going to have just a c. So the last part here would be a c. So I've just applied my rules of differentiation there. The derivative of the sum is the sum of the derivative. That's all that I've done there. Now at this stage, I will then argue using this argument here to say the gradient, the slope of the tangent, is the same as the derivative of the function at that point 3 over 2. Because the gradient, remember, is the derivative. So now here we're going to have mt is equals to the derivative of this function at 3 over 2. Now look at how this question really quickly transforms. We know that the mt, we were told that it's given by negative 15 over 2. So here we're going to have a negative 15 over 2 being equal to. Now here we are looking for the function value of the derivative, right? We're looking at the function value of the derivative. It means we are going to put here the negative 3 over 2 in our equation. So that then now I have a 6, a 3 over 2 squared, plus 2b, a 3 over 2. And we're adding here the c. Again, I don't like fractions, so it means I'm going to simplify this to a point where I remove the fractions. So here I'm going to have a negative 15 over 2 is equal to. Now if we say 3 over 2 squared, we're going to have a 9 over 4. Then if you multiply 9 over 4 by a 6, we should get here a 27 over 2. And on the second term here, the 2 and the 2 would cancel each other out, so that I'm only left with a 3b plus the c there. Now we are going to multiply both sides by a 2, and this side I'm multiplying the 2 each term by a 2. Now when we do that, you would see that my negative 15 over 2 will only be a 2, and here I'm only going to have a 27, and when you multiply 3 by a 2, it should be a 6b, and here we are also going to have a 2c. Like we did in the previous one, I'm going to group these two together so that I have now here a negative 15 and a negative 27, and the combination of that should give me negative 42, and I'm going to still have the 6b and the 2c. And really, I can then now call this equation 1. Now, when you look at the two equations that I've done here, they're actually simple equations to work with because they are really simultaneous equations. Let me try to do this so that we are able to see our equations here that I'm working with, because we have a lot of working outs that we've done now. So these equations are linear equations. And linear equations are really easy to simplify because, the simplest way to do them is to do elimination method. I can simply say equation 1 minus equation 2. So I can say here that equation 1 minus equation 2. And when I do that, I'm going to have a 3 minus 42. Because remember, we're having a minus here. So that means I'm having a 3 plus the 42. And if you say 3 plus 42, it should be a 45. And now we have 3b minus 6b. 3b minus 6b, that should give us a negative 3b. And we then now have the 2c minus the 2c, and that is simply a 0. And this would mean then our b would be equal to, now here I'm having a negative 3 divided by negative 3. The negative 3 and negative 3 cancel each other out. That's why I have the b here. And we're saying negative 45 divided by a negative 3. guys, we all know that that is a 15. And that is what we were expected to deliver here, to say B is a 15. Now, to find the C, I can use either of my equations, equation 1 or equation 2. I will just choose to use equation 2. So I will say here from equation, well, I'll use equation 1. I'll say from equation 1, we have a 3 is equals to 3b, but the b now we're saying it's a negative 15. And we are adding to that a 2c. And really, to simplify this, you would see that if I say 15 times a 3, I get a negative 45. And if I take the 45 this side, I'm going to have a 3 plus 45. And 3 plus 45, it should give me a 48 is equals to 2c. Now we are going to divide both sides by the 2 here, and this one cancels, so that I'm having a c to be equal to a 48 divided by the 2 should give you a 24. And that's what we were required to really prove, that the c is a 24. Now this means that my equation will then now be given by, my function will then now be given by 2x to the power 3. And we're having here, remember that my equation was such that I had a b squared. So we're saying it's a negative now. So this means I'm going to have a negative 15x squared. And we are having a cx there, and our c is 24. So this means we are going to have a 24x as our equation. This question takes up 5 marks. Now the first mark that you are going to get here, it will be for you to do equation 1. So from start to finish, from the beginning of the question to getting to equation 1, you should spend a minute there. The second mark will come from doing the derivative of this function, and also being able to see the fact that the tangent and the function at the point P have the same gradient. So at this stage, you have about 3 marks. And the other mark will be really for you to simplify and getting to the second equation. Now, the last mark really would be a mark that is reserved for simplification. So this mark will be for simplification. So we just give you 1 mark for doing all the other simplifications involved here. You know, squaring, dividing, and removing fractions and all that. Now, you're not going to get a mark for finding B and C. And that is because already they've given you B and C on the question. You know, the other thing why also you won't get a mark there is that if this question you are unable to answer it, you can't get these answers here. You can still continue to solve the question because you can use these numbers to answer the questions that follow. So question 9.2 says calculate the coordinates of A and B, which are the turning points of F. Now, if you look at A and B, they are really the turning points of A and F. Now, to get these turning points, what we are going to do here is that we know that turning points are stationary points, meaning they occur when the derivative is equal to 0. So that means is either you can look for the derivative of this function because we know it, or you can come to this equation where already we took the derivative and you put the values of B and C. And that's what I'm going to do here instead of taking the derivative. But even if you do, you can try that and see if you get the same answer as I will get it here. If we use the equation that we have done at the top for the derivative, we know that we are going to get the 6x squared plus 2bx plus a c. But we are saying here that our b is a negative 15 and our c is a 24. This means our derivative will really come down to a 6x squared minus a 30x plus 24. But because we are looking for the turning points, we are going to say that at the turning point, our derivative should be equal to 0. because the turning point is a stationary point, and we know that the derivatives at the turning points are 0. So what I mean by that, just to give you a revision, a quick revision, is that if we were to draw a tangent here at B and draw a tangent here at A, the gradient of this tangent would be equal to 0. That's what we are saying here. And we know that the gradient is the same as the derivative of the function at that point, right? So f prime 0 is equals to 0 as well. So it means if we were to take the gradients of these functions or the derivatives of these functions at these points, they must give us 0. That's why we say here the derivative should be equals to 0. Now, what we then do now is that we are saying this derivative is actually equal to 0. So that means I'm going to then now come here and say the 6x squared plus 2, no, plus a 30, not a 2, plus a 30x plus 24 should be equals to 0, because that's my derivative. And I can reduce this down by actually multiplying the whole thing by a 6. So if I not multiply but divide, if I divide everything here by a 6, I should be able to get x squared plus not 30 anymore. I should get here a 5x, and I should get a 4 is equals to 0. And now this is a very simple binomial to do. Again, we've been doing this from question 1 of algebra. It should be very boring for us at this stage to really find even the factors. So that is what I should get them. But remember, I'm looking for the coordinates. That means here what I found the x values. I found that the x value here is actually a 1, and the x value here is really a 4. So what we're saying is that if we input 1 here, what value do we get here? We need to find the value of y here. If we put a 4 here, what value do we get here? We need to find the value of y. So that means I have to go to my original function and find the function values at those points, at those turning points. Well, luckily, I have my equation here. Wait, no, I have my equation here, and I'm going to use that. So I'm going to say here that the function value, if x is 1, I'm going to have the 2 1 cubed plus, well, no, it's not a plus, it's a negative 15 1 squared plus 24 times 1. And if we pull our calculator here, we actually have a 2 1 cubed minus 15 times 1 plus 24 times 1. And that says to us we are going to have 11. We do the function value again for the point 4, where we're going to have a 2 4 cubed minus 15 4 squared plus 24 times 4. And this means here now I'm going to have a 4. I'm going to have a 4. Now you'll notice that here I didn't put the square, but it will work out on the first one even if I didn't put a square, because 1 squared is just 1. And here we're also having a 4, and this says then our answer should be a negative 16. Now let us look at this. We are saying here that if we put 1 here, we should get a value of 11. And if we put the 4 here, we should get a value of negative 16. That makes sense, really. Negative 16. So it means my points here, A is made up of 1 and 11, and B is made up of 4 and 16. So our final answer should be that A is 1 and 11, and B is really 4 and a negative 16. Those are your final answers. Now this is 4 marks, so you'll get a mark really from computing your derivative, either taking the original equation here and doing the derivative, or take the one that we have already done the derivative and substituting B and C. Either way, you should come to the derivative and get a mark. The other mark will come from the fact that you know that at the stationary points, the derivative is equals to 0, and which is the turning points. Listen to me, grade 12, you are not going to get a mark here because we know this. We've been doing this from question 1. What you'll get a mark for will be your final answers here, meaning if you get the correct answers for 1 in 11, 4 and 16, negative 16, because all this we are saying here, you should take a minute working them out. They shouldn't be more than a minute. I mean, this should be easy stuff for you at this level. Now, we are going to go to question 9.3, which says here, for which value or values of x is the function f? Well, the first part they say decreasing. Where is this function decreasing? So under 9.3.1, our focus is where is the function decreasing. Now, if we look at this side of the function, from here to here, the function is actually increasing. And also, if we look at here, the function is also increasing. But between A and B, the function is actually decreasing, it's going down there, it's decreasing. So my values of x will range from 1 to 4. All these values is where this function is decreasing. Those are my x values. So here, there are many ways really of writing this. I can say here that from 1 is less or equal to x is less or equal to 4. My function is decreasing. Now I'm using less or equal to because the function is defined here. So that's why I'm using that point to be less or equal to. You can also write this using the interval form where you use square bracket to say 1 to 4. That's another way of writing it. Remember, the square brackets are the same as less or equal to. Now, it is also acceptable, or you will be awarded a mark if you write this in a form of 1 is less than x is less than 4, or if you say 1 to 4 using small brackets like that. The reason being is because at the stationary point, at the turning point, the function is both increasing and decreasing. So I can argue to say 1 is not included and 4 is not included because the function is both increasing and decreasing. And our question was really actually looking for where it's decreasing. Because it's doing both of that, it is acceptable to write any of this notation. I hope what I said makes sense, but feel comfortable to either use less or equal to, you'll get the full mark. And this really should be something that, you spend a minute on, or even less. These are the type of questions where you actually buy some time because you can do them within less than a minute. Now 9.3.2, they say here we're looking for the values of x or value of x where the graph is concave down. I think we talked about this when we were looking at concavity. To say the graph begins being set from here to that inflection point. And we said the end here gives you this shape, right? So that's where it's concave down. So this graph is actually concave down from where? From these values of x here, from the values of x going there. So one can say here, this graph is concave down from negative infinity is less than x, less or equal to 3/2. Because we're seeing all the values from infinity until we get to this point of inflation, the 3/2, our graph is concave down. And again, there's many notations that one can use here. You can still say open bracket in negative infinity, 3/2. And this one is included, is always included because it's not a turning point. Or the famous one that, the notation that is famously used is to really say x is less or equal to 3/2 because all the values here, we're saying this is 3/2. All the values below 3/2, all the values of x here, they are small to 3/2. That's what we are saying here. And again, this should be 1 minute to write any of these options here. Now the next question, which is 9.4, says here, if h of x is equals to f of x plus 16, describe the translation of f to h. So you can clearly see that here we're getting a new function h of x by taking f of x and adding a 16 to it. And we actually know this. We know this translation. We are saying here that on the values of y, remember f of x it represents the values of y. So on the values of y of f, we are adding a 16 to it. So that means we are actually moving that graph vertically upwards. So if we do this type of translation, what I'm saying here is that we are forming h of x by taking f of x and adding a 16 to it. So it means we take the original function, the 2x cubed negative 15x squared plus 24x, and we're adding a 16 to it. This will make our graph to move vertically upwards. So now what I'm doing here is that I'm saying if I add a 16 here on the value of y, what will I get? Well, 16 minus a 16 would give me a 0. So it means I'm moving this point to a 0 here. And remember, this point here is a turning point. I'm moving this point to a 0. So this means I'm moving the point towards a 0 here. So this means the turning point will now be here. Again, if I take, let's say, this point here, which is 11, if we take 11 and we add a 16, we say 16 plus 11, because we are adding on the y values of f. Well, this will give me a 27. So this means I'm moving this point here to a 27. So I'm moving this point to somewhere here, 27. So my graph now has a turning point here, a maximum turning point and a minimum turning point respectively there. We can do the same with, let's say, this point here, 0. If we say 0 plus a 16, that means we are moving this point to a 16. So this point here will move to somewhere here to be a 16, is a new point 16. Now this means my graph now has moved and it looks like this. It actually moved from this point to there. And remember, we are not only moving these points, we're moving every point on this function. That's why the whole graph will actually move, because we are moving every point on that function. So to answer this question, really, we are going to say here that the graph of f has moved vertically upwards by 16 units. A quick 1 mark there for free. Now, the next question that we have here is question 9.5. And it says here the graph of the function g has the following conditions. We are told here that the first derivative at 6 is the same as the first derivative at 3. It is also the same as the first derivative at 0. And they are equal to 0. Now, what does this statement mean, really? It means that the first derivative at these 3 different points, -6, -3, and 0, is actually the stationary points. So we have stationary points here. So this could either mean we have some form of a turning point or an inflection point where the derivative is 0. That's what this means. Then they further say here that the second derivative is positive if -4 is less than x and is less than 4. So what we're saying here is that our function this is like the second derivative test. So here we're basically using the second derivative test. And we're saying that if we take the second derivative, it is positive on this interval. So it means on this interval, our graph should be concave up. It should be a positive graph. And we also say that the second derivative is negative when x is less than 4 or when x is greater than 4, meaning on these intervals, our graph should be a set graph. It should be a graph that appears to be set because the second derivative is negative. It is concave down. And we are further given here to say the first derivative is positive on this interval, x is less than 6, and also on that interval, negative 3 is less than x or less than 0. So here, what we're doing here is the first derivative test. The first derivative test, and what it means here is that we're saying the graph is positive. The first derivative is positive on these intervals, meaning on these intervals the graph is actually increasing. We should see a graph that is increasing. And here again we use the first derivative test to say the first derivative is negative on these intervals. So that means on these intervals the graph should be decreasing. Now, all this information really normally they will help us to sketch a graph. That's why the question says here, sketch the graph of G indicating all the relevant points. Let's put all this down, all this knowledge down. It's a very simple question, this question to do. You just have to know what you are doing or know your properties of derivatives. So we're looking at question 9.5. What I'm going to do here is that I'm going to construct my Cartesian plane here to say I have x, I have y, and I have a 0 there. Now what we are saying here is that the first statement is that we have negative 6, negative 3, and a 0. So we have here negative 6 and we have negative 3 somewhere here. And at those points we know that we expect to see stationary points. We expect to see some form of turning points. But when we look at our second derivative test here, we are saying from the interval negative 4 to negative 2. From negative 4, which I can sort of draw it here, from negative 4 to negative 2. So this means our graph will be a happy graph, because when the second derivative is positive, we actually have a minimum turning point. So the graph will be happy because the second derivative is positive. So obviously we know that at the point 3 here, if you look at this interval, this is where 3, it's between 3 is in between here, between this interval. So that means here at this point, we know that at this point here, there must be some form of a turning point or a stationary point. So we are saying here that somewhere on this point here, we must have a minimum turning point. We must have a graph that is doing that somewhere there. And these 2 points, they actually tell us concavity. So they're telling us that, this graph will be concave up until this point. So until somewhere here and here, we'll have a graph that is concave up until, those points, negative 4 and 2, our graph will be like that. It's actually concave up. So this is a confirmation that this is a minimum turning point, and it pushes until it gets to this point. The other condition is that when we look at the interval from any value that is less than 4, we're having the second derivative to be a negative. That means our graph should be a sad graph because, we're having the second derivative to be a negative. So if we go to negative 4 and less, here you see that x is less than negative 4 and less, our graph should be a negative. But there's something very interesting. If you look at 6 here is a stationary point, and 6 lies in this interval. So 6 is in this interval, 6 is somewhere here. So we are saying here, at some point somewhere here, our graph should have a minimum turning point. It should be a negative graph because the second derivative is negative. But from this point here, our concavity should be like that. It should be so that it's like that. So the graph here, it's concave down. But at some point here, it should have a maximum turning point because the first derivative here is 0. But this concavity also occurs on values that are greater than 2, negative 2 I mean. So if we come to negative 2 again here, we see that we should also have some form of concave down. But we know that at the point 0, we have a stationary point, we have a turning point. So it means at some point somewhere here, I should have a turning point that goes like that. And really my graph will then go on like that. So from this point going forward, the concavity is such that this graph is concave down. But we know that at 0, our stationary, the first derivative is 0, so this is stationary point, is a turning point. Notice that the points 4, negative 4, and negative 2 are points that traces our change in concavity. And that would mean that these points, they are points of inflation. That's where our graph will have some form of point of inflation there. There's other information that we are given here. We are also told that the first derivative is positive, right? When we look at any numbers less than 0, this means that the graph is increasing on any numbers that are less than 6. So if we look at 6 here and the numbers that are less than 6, you can see that this graph is actually increasing. So this just confirms the shape, the graph is increasing. But also, it is also increasing between negative 3 and 0. So if we look at negative 3 and 0, you can see that the graph is increasing. When you look at this statement and you can confirm the shape on the graph, you should be smiling because it tells you that you found this graph to be correct. You are doing the right thing. Then here we're seeing that the derivative is negative, meaning the graph is decreasing between negative 6 and negative 3. So if we go to negative 6 and negative 3, you can see that the graph is actually decreasing, is going down. So again, that is a confirmation, and it gives us confidence to say we have done the correct thing. Now this is only 3 marks. It means it should take you 3 minutes to answer this question. Not really difficult. You just have to understand your first derivative test, second derivative test, and understand also the stationary points, that when you take the derivative and it's equals to 0, it means it's a turning point. So you'll get a mark for getting the correct shape, and you'll also get a mark for doing your turning points. Both these turning points will give you 1 mark. So for getting the turning points, and you'll get another mark really for understanding that we're having increasing and decreasing here, meaning plotting these inequalities here. So that will be another mark, and that should be a total of 3 marks. Now I have to mention that here the shape will always be the same. You should get a shape that looks like this. But the graph can also be somewhere here at the bottom. Those are the options that you will have as long as you have the correct shape. But also the thing is that it has to be within these numbers. You can't have this graph on this side because you don't have these numbers this side. So as long as it's anywhere this side and it has this shape, then you'll get your full marks.